Good morning, everyone. Good morning. I didn't expect a full house on a Sunday morning at 10 o'clock after a Saturday night, but there we are. It's great to see everybody here and almost not a seat to be had. My name's Mark Smith, and you may have seen me on the video before there. I run the IBC Accelerator Media Innovation Program. It's a program that's been running since 2019, and we had 3 projects. It was a very nascent program. It's a program that helps to facilitate collaborative innovation in the media and entertainment technology ecosystem. So we're here to bring the buyers, the champions, the broadcasters, the studios, the people who come here to IBC to buy kit, together with the participants in the projects who are the vendors, the solution providers, the application developers, systems integrators, the vendors, who work together collaboratively in projects. So we had 3 projects back in 2019, and then the pandemic hit. And I think if that did anything over the last couple of years, it accelerated the strategies of almost every company around virtualized production and remote production. And so I think that's right time, right place for a program like this, where we were working globally and virtually anyway. We had 8 projects in 2020 and 8 projects in 2021, all of it done virtually, and the showcasing of the solutions and the proof of concepts at the end of the cycle were all done virtually. So this year it's fabulous to be here back at IBC with 8 great projects, and you can see them all over here. Each of the projects has a pod, and they'll be showcasing their solutions and their proof of concepts. You can come and meet the teams. But just to reiterate, it's a framework for collaborative innovation, and it's IBC investing back into the industry. So really important program, and I think you'll hear about the sense of value that these guys put in working together, in understanding not only their own pain points, but those of others, and working to really progress the industry together. So with that, I'd like to, before we get into our project that we're going to focus on today, which is cloud-based live events, and we're looking at low latency and analytics around the whole of the cloud production workflows. Before we do that, it's my pleasure to introduce our sponsor, our premium sponsor for the Accelerator program, Aaron Beeman, come on, who is the global lead for media and entertainment sector with AMD. Thank you so much for sponsoring. Do you want to say a few words, Aaron?
Yeah, sure. Thank you, Mark. Thank you. Here at AMD Xilinx, media innovation is something that is certainly near and dear to our hearts. From rendering visual effects and animation for some of the most ambitious films that are in theaters today, to virtual production, emerging workflows and content creation, to both hardware and software-based transcoding at scale, to powering the CDNs that are ultimately delivering content to consumers. This is a space that we've invested in for decades, and very excited about this project, and look forward to hearing a great session today. And we would love to bring forth additional partners that could potentially collaborate, companies such as Red 5 Pro, who are streaming to millions in milliseconds in watch party formats. So, with that, I want to give the stage over to the team, and thank you all for attending today.
Thank you so much, Aaron, and thank you again to AMD. AMD is our premium sponsor. Our program sponsor is Microsoft, and I'm delighted that we're going to welcome the first panelist from Microsoft. Again, thank you to Microsoft for helping sponsor and get this program off the ground. Welcome Scott Davis from Microsoft. Come grab a seat, Scott.
Sure.
Secondly, I'd like to introduce Jonathan Hale, who is with Warner Brothers Discovery, contribution engineer at Warner Brothers. John, grab a seat.
Thank you.
And then I'd love to welcome, if I can see, because the lights are right behind you, but Caroline Ewerton from DAZN, Head of Product Technology Solutions at DAZN. And then it's my great pleasure to welcome a real old friend of the Accelerator program. He's been involved for the last 2 to 3 years, I think now, Mario. And he's had a little job on his hands called the Olympics for the last few years. And this is Mario Rice, who is the head of telecoms at the Olympic Broadcasting Service. So what a team, what a team. And we've done some great things, I think, haven't we? I think you all have worked incredibly hard since this was first pitched at Kickstart Day in April. And I think they were originally 2 different projects. So I think the original idea, Scott, was pitched by Microsoft.
Right.
And it got such significant traction amongst the champions.
Yeah.
And you pitched a project around cloud-based live workflows, and then Mario, you pitched around low latency.
Low latency, yeah.
And these things came together in one project. So perhaps you want to just explain a little bit about how that happened and why that happened.
Well, our question was really, is there a business case for low latency in 2022? And if yes, how we can deploy it, what are the constraints, what is the current state of the market. But I think more important was really to develop a baseline to be shared with you guys from where we can start working. And if nothing else happens, we start asking ourselves the question, can we improve the user experience when it comes to streaming? If nothing else matter, you know, if I don't do betting, which I don't do, if I don't do e-gaming or interactivity, but at least there is one thing that I believe low latency can bring, that is we can improve the user experience to our clients. And I think that was the starting the starting point of this idea, and the objective was really to define a baseline.
Yeah. So in production or in the distribution side, which side did you have in mind when you first proposed this? And
actually, I was more focused on the distribution, and so from the end user perspective. And I think with Microsoft and Discovery Warner and we came together on the contribution side and on the production. And I think it's perfect, because obviously there is a blend and there is an integration, and this is a complex ecosystem anyhow. There are different protocols, there are different tools. Each one of us, we have different workflows. But regardless, I think the objective was really to define a set of common architectures, but also to define properly and set right expectations. And a little bit to declutter from what, with all the respect to our marketing colleagues, but what marketing says, what we can do right now. And I see some faces. With all the respect, marketing is very important. But when it comes to operations, hey, the question was, what can we do in 2022 or 2023, not in 2030? It's important as well, but maybe it's a different accelerator.
thank you, Mario. So, Scott, Microsoft pitched actually, I think, three ideas last year, and this one just seemed to grab this attention and traction, and you can just see the caliber of some of the champions involved in this, from BT Sport to Warner Brothers Discovery, Olympic Broadcasting, Paramount, which of course owns MTV and a number of other properties, DAZN, of course, as a disruptor, I guess, in the sports broadcasting sector. So ITV, BBC, TV2 from Denmark, and BT Media and Broadcast. So an incredible array of champions there. And then just, I mean, an astonishing industry ecosystem in itself here in terms of the participants. Just talk us through what Microsoft had in mind with this at the beginning.
Sure. So I'm originally a streaming guy and a broadcast media guy, so I was very much aligned with what Mary was saying about trying to do ultra-low latency. Participating with so many of the broadcast community, they were also very concerned about, could we bring more of the production capability into the system, into the cloud? Also looking to make sure that we could decrease the amount of latency and improve the overall capacity for doing more production seamlessly against what we're already starting to see in the streaming community, happening in legacy and VOD, but more in live. Jonathan was instrumental in bringing a lot of production value, along with our friends like Matt from Paramount, to go, what are the things we're doing today and how do they work well, and what works efficiently versus operationally needing a lot more hardening. And as we were looking at it against the partner ecosystems we see, not only with ourselves, with our friends over at GCP and AWS, what are the things that still need a little bit more love and understanding? We certainly took a crawl, walk, run approach. Many of the things we started out with were, what are the things that we thought worked okay but could use some tweaking? Could we start with HD and move to UHD? Could we start with a symbol encoding profile and move to more interesting encoding profiles? And finding out where were the pain points that we as a system ecosystem partners and professionals work on to make better and expose where the weak points are, so we could work together more efficiently and point at the areas where we still had work to do.
Yeah, great. Let's take a sort of a big picture view, and Caroline, maybe we can talk a little bit about what our goals were, some of our aspirations. What was the strategy behind this, I guess?
Sure. When we made a decision to join this accelerator, we had a sort of very real user case in mind. We've recently acquired a major right in Spain, for which we need to move some of our production activities for sort of some of the what we call bronze production that we do So not gold, not silver, the bronze stuff, into galleries. So I looked at the product roadmap and I look at all the challenges we've got going on. Like, we know that 1080p is coming in the next season. There's already stuff going on in 4K. We are already building a cloud gallery for the lower tier stuff. So sustainability goals, all of those things. And then we thought, do we really need to build traditional galleries? And unfortunately, at this day in time, we still do, because we need those galleries in 6 months' time. So this was really an opportunity to come together with a group of people to look at, how far are we from being able to make this a reality? So there were really 3 things we wanted to establish. One was what is the reality of the state of maturity of this technology, as Mario was saying, 2022. So not 2 years from now, not 18 years from now, if we can't deliver a high-tier event live in the cloud today, how do we get there? And then the second thing we wanted to look at was demystify production complexity. So, how far can we push the production activity? Could we do today, if we were to take a risk, a full bells and whistles gallery production, for something like La Liga, for example, domestic in Spain, with animated graphics and all sorts of things in the cloud without sacrificing quality and latency too much. And then the third thing was, as a direct-to-consumer, as a B2C, what do we actually get for the customer? How do we improve the customer experience from doing this so that we are not moving to cloud just for operational efficiency regions? We're actually able to deliver a better customer experience, both editorially as well as quality. So those were the key things.
So essentially, that's sort of establishing the maturity, and then trying to demystify some of the things that you and Mario talked about, and then, of course, the value, defining some of the values around these things. So that's very clear. That's where we set out. Scott, just some of the background challenges. You talked a little bit about them, but what were the kind of more specific tactical things we wanted to try?
Well, great question. People are going to look at this slide and go, but we're already seeing this. We're already doing this. I can walk out on the floor and I can see this today. People are doing it. Pretty much every one of these came with a caveat of, we see this working, but almost every champion said, but I've got a case where it kind of doesn't. Transporting streams into the cloud is something pretty much every vendor has a solution for, but there was always an asterisk of, it doesn't quite work well if I do this. Or in these conditions, I have an issue because of X. And we went on for quite some time in the Accelerator program talking through it. Could we synchronize cameras? We spent a great deal of time a couple of weeks back just kind of sitting there looking at how can we get the cameras together, and we were very fortunate the cameras worked very well in synchronization. We think there's still a lot of work to do to be able to push that a lot further. You'll see we talk about HEVC, I can speak.
It's difficult on a Sunday morning, that is.
Especially when you're late for your own panel and Mark has to call you to come running to your panel. Our world is still very much an AVC H.264 world, and there's a lot of pressure against doing HEVC in the cloud because there's still a sense by some people that it's so expensive in terms of compute. We wanted to take a look, could we push HEVC all the way through? Can we do UHD workflows? Because we're getting into a world where we're going to start seeing more super resolutions like 8K. We're going to see more HDR, more UHD. We're going to see people move 12 and 16-bit workloads through these systems. What is the impact going to be? And what changes would we have to, what levers do we have that we can pull that'll change latency, quality, cost, and performance? And what would that overall do?
Great, perfect. Scene setting. John, you've been sitting here really patiently. And you've really been the guiding force on this project, if I might say so. You really have. You've really led everybody through this. So let's talk a little bit about. Let's give you the floor to talk a little bit about how you guided and what we were trying to do, and then ultimately, what were the very specific things that we did through our 2 days of testing in the studio. So, I think 2 years ago it was very primitive to be able to say this it wouldn't have been reality, would it?
Yeah,
we've come a long way in 2 years, haven't we?
We have, yeah, and this project is really the culmination of 2 years worth of development within Warner Brothers Discovery, looking at cloud technology and how do we bring it in. And we started off with probably one of the biggest 2110 facilities and builds in Europe, and it's looking at what we're doing there. How can we actually do that in the cloud? And when we start doing this, it leads to lots of conversation and calls, and we can talk for hours and hours and hours and hours about this. But the only way to really find out how it works is really to jump in and do it, make some mistakes, and learn from them. And really what we're saying now is live cloud production is really here. It's been 2 years in the making, but for us, we're really seeing it evolve from the low bitrate streams that really prohibited a lot of productions at the start, because we just couldn't get the streams from the event up to the cloud because the cloud production systems just couldn't decode them and take them in. But cloud production is really like walking a tightrope. Sorry, Mark, that's a bit too premature there, but that's what this slide is about.
Yeah, it's risk-taking. That's why I moved it on, because you
Exactly.
talked about risk-taking, and you do need to be
Of course.
brave in this context.
You do, and it is like walking a tightrope. You know, you can't just jump on and walk across it and put all of your key rights up into the cloud on day one, because that's just really irresponsible. Like, you would never just run across a tightrope with zero experience. But it's about putting the safety nets in around that at the start, so you kind of de-risk it by just having this long kind of standing development project to gradually raise the rope every time that you move forward. And we're really seeing this now at quite a high level, and we're really achieving quite a lot of things. And it's great to kind of come into this project and really test those things and move it forward.
So what did we achieve?
So one of the real key achievements was taking it end to end in the cloud. So today people have got a lot of cloud production, cloud playout chains, and a lot of it relies on on-premise kind of dependencies. So that means taking it into your on-premise facility, taking it through a device in a server rack, maybe just doing multicast to unicast translation, but that's still a physical piece of kit on-premise. So if you're doing that, the first thing when you have a cloud migration project, you don't want to work out how many racks do I need on-premise to support our cloud platform. So we kind of see the end-to-end approach kind of solving some of the challenges around that. And what that is taking streams from the event into the cloud on the first hop, so not coming into your private network at all. And we kind of pushed that forward with the Olympics in Beijing. So we pushed all of our traffic up through a cloud provider and then brought it back down into our 2110 tech hubs. And that was a significant amount of traffic, and that was J2K streams, that was H.264 streams. In some cases, it's up to 40 gigs worth of traffic traversing the cloud and then coming back down. So it kind of, once you've got it in the cloud, you can then start processing it and doing things to it. So we kind of see the end-to-end, so contribution in, media processing, OTT distribution out to the player, and also feeding other different legacy workflows on premise potentially, really being the way forward. If you start off saying, right, we're going to put everything through our on-premise production facility, that means that you end up scaling racks and racks and racks of kit still on-premise. And another achievement is multi-camera production. So that's taking multiple camera feeds in from our MTV event that we did for this, and that's vision mixing them in the cloud. And for that, they obviously have to be in perfect synchronization, because you're taking an audio track and then you're embedding that onto the multi-camera approach. And a really, really significant step up is what we've seen here, is we can now do UHD HDR in the cloud. So that's really been started to be tested as part of this project. And the vendors that we've engaged with on this have been great, and they've supported it. And we can now really take UHD up in 90 megabit HEVC HDR. We can vision mix the streams, we can put graphics over it, and then we can then send it out to an OTT encoder, an ABR encoder. We can also then bring it back down on premise and decode it to 2110. And that's really the start of something significant and something special, considering that 2 years ago we were looking at 5 megabit HD streams was kind of the limit of things, and now we're looking at UHD HDR production in the cloud. And also part of this project was the low latency approach. So it's really end-to-end, what can we achieve in as low a latency as possible? And we've kind of really pushed the boundaries there as part of this as well. But it's also about the operator latencies and figuring out when you push a button how quickly something responds, and how that's okay for some productions to have a bit of latency, but others it's not so much okay.
So what did this look like, John, in terms of reality?
Yeah, so this was our multi-camera feeds coming in, and then we were producing a mixed output out of that. And this was one of the things that surprisingly just worked. We had the feeds coming up from encoders on the ground as HEVC streams. into a multi-viewer and available to a vision mixing and audio mixing components. And it just works. They were in synchronization, you could cut between them, and visually they looked okay. We did some analysis on that, and we put the same feed up to all of them, and we figured out that some of them are about 1 frame out. So it wasn't perfect synchronization. But there are techniques now that you can do to really kind of lock them all together. So it's taking NTP time into the encoder and time stamping that into an SEI timing PID, and then the cloud production system decoder sees that, it has a small buffer, and then it realigns all those feeds based on those timestamps. So we didn't actually enable that for this because we thought it was okay being maybe 1 frame out, and we didn't want to put that added buffer in because it would be a bit more kind of latent. So we just decided to go with it as it was. But I think if we had a bit more time, we would have played around with that a bit more. And it's obviously something that we're going to be deploying in future for multi-camera productions like this.
I think we should say, in the interest of transparency, but also a little bit of background about what this was. So we had originally planned to do this live, hadn't we, with an MTV production, part of Paramount. And this is called the Isle of MTV, which happened in Malta in July. The original plan was to do it all live, and the engineers all being on location. But then COVID hit, didn't it, in the middle of July?
That's right,
and most of the team were grounded and not able to travel. So what we did was take all of the footage and then put it through the studio as live.
That's right, yeah. So it was recorded all to EVS, and then when all the kit came back to the UK, it was set up as it would be at the event, so using the same encoders and the same kit, and instead of the actual live camera feeds coming back, it was just the EVS output ports being played up.
So, I mean, and this being a music event as well, perhaps a sporting event might have shown some of the sort of impact of some on the latency aspects that we were kind of looking at. But for music, you've got some really interesting learnings and insights into how a music production is impacted by some of these things as well, I think.
That's right, yeah. There's a few slides coming up, and with kind of, this is our workflow. I'll talk about this first, maybe.
Yeah, talk about it first.
Yeah, so we've got the live event over there, which is where we had our HEVC encoding stack, and then we were bringing that into an input stage into our system in the cloud. And there should have been video there, but I took this screen grab after the event because during the event we were very busy trying to get stuff working. So we had 8 incoming OSs, so SRT decoders. So that's then being passed through into our vision mixing stage, and we're actually bringing in kind of external graphic systems. So we use Singular Live to overlay graphics. It's all going through a big audio mixer, but really all the audio mixer was doing was just having the audio mix from site coming up. So it was only one audio track that we were overlaying on top of this. So that was then the program out was going into a H.264 encoder, and it was also going into an HEVC encoder. So we were kind of providing both an H.264 and HEVC output to a common distribution point in the cloud. So this is kind of where Zixi and NetInsight came in. So we really put everything to them, and everything was traversing through this cloud routing point. Because part of this, it was also going to feed a cloud editing system. So we were going to put the streams up once, and then they were going to be distributed into our production stage and also an editing stage. But it also helped on the distribution stage because we had multiple ABR encoders set up doing different protocols. So rather than duplicate that all on the vision mixer, we duplicate that on a distribution point in the cloud, being Zixi and NetInsight. So what you see here, we've also got the OTT return feeds coming back in to our cloud production system dashboard, so we could monitor them in real time. And we did this so we could put a clock, and we've got a clock being generated on the vision mixer, and then we can then see the clock coming back in from the OTT returns coming in. And all this was we just spun up some PCs in the cloud. We installed NDI on them. We just pulled up the OTT returns on a web browser, sort of full screen them. So we had the feeds coming back in as NDI then to the dashboard that we've got there. So we could monitor this all in real time, and any changes that we made and any drift in latency were picked up in real time on this dashboard. So these are all kind of live video feeds that you see on there, so anyone looking at this can kind of see the latency through the system. Unfortunately, we didn't get to capture the end-to-end latency because we were struck down by COVID, and there was quite a few things going on that kind of really prohibited us, a few challenges there. But we kind of did it in isolation, and we're going to talk about the latencies a little bit more in detail later.
So, benefits and flexibility that we kind of found through doing this. What sort of things were we?
Yeah, so we
Scott, feel free to jump in because you were part of these tests as well.
No, John, you've got it. It's your thing.
Thank you. Yes, so really we kind of deployed a graphics solution there, external from the cloud production system. So this is really breaking things out of the box for the first time, because 2 years ago they were very single box solutions where you needed one vendor to do everything. So you had a vendor that made a really good vision mixing system, but they didn't have a comms system. So we said, look, we love your system, but we need you to build a comms system. And it's just not really in their area of expertise. So kind of deploying a graphic system external to that is really the start of something special. And we also deployed a lot of automation on top of this to make things really simpler for the user. And that's kind of automating instances in Amazon, deploying them and tearing them down. And it's also production automation as well. So creating like complicated production switches into macros and then putting one button behind them. And cloud is great because of redundancy, right? But kind of how do you access that in a production sense? So I'm going to talk a bit about how we achieve that here. So this is really our kind of cloud native graphic solution. And what this is it's a graphic solution singular live, which was really born in the cloud. So it can really only run in the cloud. And it was designed all around cloud in mind. So that's what I mean when I say kind of cloud native. And what this is we kind of put this down to a common user interface with push buttons on it. As you can see there, we've got a Stream Deck, so everything that operators needed to do to control the system, including the cloud infrastructure, deploying it was put to a single push button interface. So in this case, what this is it's the cloud production system, GVAMP, talking to the API of Singular Live to overlay graphics, lower third, and trigger them. And these are running on two different systems and by different providers. So we're really seeing that kind of API integration come on between two systems, being the control system and a third-party system running. And that makes it really, really powerful for operators just to simply push a button to trigger a graphics rather than having to quickly navigate over to another web user interface to trigger graphics, then back to the vision mixer. So we're really trying to do a lot of work now to make the user interface for operators really, really simple.
When I put this slide on yesterday when we were talking through, somebody thought that the graphics had all gone wrong at the action. This is probably the most boring slide here we've got today.
I completely agree. This really doesn't look interesting when you say what. I mean, some people know what that is, but this is also really the most interesting and powerful thing about cloud. And it's really the holy grail of what broadcasters have been chasing on-premise for years and years, from what I can recall. And it's the ability to kind of deploy infrastructure just by pushing a button. So it's deploying kind of Python scripts in the cloud to orchestrate spinning up instances and tearing them down. And again, we kind of did this, as I mentioned. So we put it behind a push button interface that made it very, very simple. And it's also kind of the automation around the production side as well. So that's we attempted to try and get it as simple as possible. So we had 4 kind of key buttons. One of them was a start show sequence. So when you push the start show, you got a title sequence running. It faded up some music in the background. After the title sequence had finished, you then had a transition into like a beauty shot. From the beauty shot, it then had another transition into where you wanted to start the live with. It then faded up the audio for the live and then faded down the music. So it's really kind of trying to put these complicated production moves behind a single button push. And that's by no means going to replace a big PCR with lots of skilled operators in it, but it just means that you can kind of simplify things. And it is kind of good for like the lower tier stuff where you just want someone to push that button then, that button then, and that button then, and then that's your production kind of done.
So it's the really holy grail of this, any facility, really.
I think provisioning infrastructure from nothing is hugely powerful.
And Matt Akote actually popped in right while you were doing that and said that's exactly what he's doing in his production system for his Tier 2 events at Paramount. He's bringing in less trained people, and they're good to go to do operations today without having to do significant amounts of training to get started, get going, and then learn the more complex production stuff later.
Yeah.
So you're enabling a wider group of people to go faster, earlier, so we can increase the amount of people who can do this. As we run out of people who are able to understand what we're doing.
Yeah,
Exactly.
Big thanks to Matt Akote. He's the lead production engineer at Paramount, and he kindly handed the studios over to us for a couple of days to be able to do this. He's not here, unfortunately, today because he had a wedding back home, but I wanted to say thank you to him and Paramount.
Yeah, correct.
So that's some of the key things around the automation. What about some of the things around redundancy models?
Yeah, so we built a true real 1+1 system redundancy model. So what that is that's having two systems running side by side, doing the exact same thing at the exact same point in time. And these were two systems, one running in one region and the other one running in the other. And what the kind of automation system allowed us to do was when you cut to camera one, both systems cut to camera one. So it was an identical mirror of each other. So we could have a complete failure on one chain and the other one would just operate. And you can really push this quite far. So you can start also kind of doing regionalization to it. So you see the kind of key and fill graphics we've got there. Like on the other system, you could replace that with a different look for maybe a different audience, and it could all be controlled by one operator. So when one operator does a mix, it's going to build an identical mix on another system.
Do you know of anyone that's building that kind of redundancy into the on-premise side of things today?
I think on premise it's really hard, isn't it? And you might not necessarily need it. But I think it lends itself to the regionalization as well, and bespoking like a custom kind of graphic or output, because one system could have one look for like a younger kind of audience, and the other one could be a bit more mature for an older audience, and then you could have one operator controlling all of that.
On the redundancy side, typically we'd see a 4-to-1 or a 5-to-1 redundancy where they'd have 4 sets and they'd have one redundancy they could flop to. Here, you could have dual redundancy ready to go. Nobody can afford to build 1-to-1 redundancy in hardware right now.
So talk about the UHD workflow.
Yeah, so this is our UHD workflow dashboard, and it's the exact same system, but it's kind of different applications running. But fundamentally, it's the exact same workflow that we're doing. So for this, we didn't have it live from the event. So it's a TS player that we've got. But this was a 2160p 50 HLG stream. It's encoded to HEVC 90 megabits, and we're bringing that up to the system 8 times. So that's 8 feeds going in. Going into the same kind of vision mixing processes, and we're also generating graphics on the system as well. So one of the challenges around UHD, you think, oh God, I've got to change all my graphics to UHD, and in some cases you have, because like you might want them to be in UHD and look really good, but as part of this we're able to just use the same HD graphics and overlay them over the top. And because they were just really discrete graphics, you didn't notice them not being UHD because it was a small bug or it was a lower third graphic appearing. And there you've actually got the CPU utilization of the system there. So we're doing the bulk of it all in GPU. So that's the vision mixing and the heavy loading. And then you can see the CPU usage around that, which is the UHD decode process and the encode process happening. So that's all going out. You've got a program output going out to an HEVC encoder. The encoder's set up in the same spec, so HEVC 90 megabits. And what we did with this, we put it into an ABR encoding chain, and you can see that as a dash low latency stream just up there. And then just below that, we also took it back on premise and decoded it to 2110 and made it available in our tech hubs.
So let's get to some of the elements around latency and the challenge around particularly operator delays.
Yeah, so everything worked really well, and but one of the challenges that we picked up was it's around the operator delay and how he uses the system. And in some cases, the delay's okay. You might not notice it. For live sports, you might not need cuts to be absolutely when you push the button. But for live music, we picked up that maybe it's something that does matter, to be really creative with the music. When you're making cuts, you want the cuts to be on the beat. You want them to be on the kick drum, or you maybe want them to be somewhere else. So when you push a button, it absolutely has to be dead accurate. And something that we noticed here, like this is a typical beat that was going on in the background. It's not going into a music lesson now, but it's just a key thing that gave us a timing point to time when we pushed a button to see when something happens. And really, when we cut on the kick drum, we noticed the cut happening around the snare drum. And kind of what we worked out, that this was around 120 beats per minute track. So that equates to 2 beats every second, which means we were around 500 milliseconds out. But we didn't really have anything to time exactly what that was, but it was kind of just before, but we noticed there was a bit of latency there. So for this, we could kind of work around that. If we cut on the snare drum on 4, it would actually cut on the beat on 1. So there's ways to work around it. But coming here and cloud production development is moving really quickly all the time. And just coming from IBC, we feel that we've really resolved this now. And there's tricks you can actually do in the system to offset that. And we're also seeing things like JPEG XS resolving that for us completely on-premise. So our on-premise system is we've got all the kit in technology hubs. We've got all of the operators not in the technology hubs. They could be in Paris, they could be in Germany, they could be in Italy or Spain. And they're all controlling the kit remotely and looking at that via a low latency JPEG XS stream. And that delay is around 40 milliseconds. So it's around 1 frame of video. So when they push a button, they actually really see that latency not there. It's a clean cut because it's 40 milliseconds, so it's very hard to see 1 frame of video. And in some cases, it's also sub 40 milliseconds, so under a frame of video. So part of that, how we resolve that, is using JPEG XS. But JPEG XS is quite high bit rate, and if you want to do a cloud production that hasn't got a JPEG XS decoder and hasn't got the bandwidth to receive it over the internet, it doesn't really lend itself to that. So coming to IBC, we've kind of found RDP technologies that resolve that and really get that within the kind of latency that we have on premise, being within that 40 millisecond mark. And also talking to vendors, we can also figure out how we can kind of artificially change the system to visually get rid of that latency as well. So that was the only real challenge that we really had on the production stage, and we're almost half the way to resolving that already. So the development cycle of this is just moving so quickly. It's like every week we're resolving issues and challenges. And 2110, we absolutely need it on premise. It's brilliant, but some of the challenges there, you know, we're not really seeing them being resolved, and that's very slow moving. And you generally need a multi-million-pound budget to jump into 2110 and develop it and move it forward. But with the cloud, anyone can jump on a system today. You could go see a vendor, get your laptop up. For $7 an hour, you can start developing and start assessing it for yourself.
So let's move to some of the findings, because we're getting short on time now. But Mario, talk us a little bit. I mean, we found that we think that IP is solving the latency challenge here, and talk us through that kind of end-to-end latencies. From your perspective, what have you kind of found with this project that's been informative in everything you do?
Yeah, I think right now the question of IP is solved, so I think we take it for granted. What we see here, and that was the purpose of the Accelerator, was really to take the 3 main streaming protocols, low latency, HLS dash and HESP.
Good job.
And play with them. And these are the results. Obviously, what John was saying. So obviously, we had to do this in a certain controlled environment, though, in order to get some results, as I was saying at the beginning, to get the baseline. But what we see is this difference in terms of latency between HESP, the high efficiency streaming protocol, 4 seconds approximately end-to-end, with Dash low latency 7 seconds, and with HLS 9 to 10 seconds. And we think this is a good baseline to start with. A couple of points, and I think Carolina as well was mentioning at the beginning, you know, getting from 7 seconds or from 10 seconds to 4 seconds, maybe for some of our applications, I mean, in sports, for instance, so what? Yeah, we may ask ourselves why we need. But I think that one important thing we need is because we can take advantage of these 6 seconds of that we save to play with the application, to offer a better user experience because here in the accelerator, obviously, we could not simulate the internet access conditions. And that's actually the big factor. But this factor, I cannot simulate, well, we understand, but it varies. And for all of us here, and I think for some of you, maybe we have some good internet access conditions in our own regions, but when you look at the world, well, there is unfortunately a good percentage of the world population who does not have access to broadband internet access. And this is a good 40% of the population. So it's important that we take advantage of these 6 seconds and we buffer somehow for unpredictability of the internet access. And I think this is one important takeaway. The other thing that I believe it was important is, for instance, in the Olympics, for OBS, we are still in low latency, in HLS. That's true, but that's true because of the requests that I get from my clients. But I think the takeaway of this is the 3 protocols, they are here. If you really want to move to low latency, if your clients, they do demand, we know that there is this difference of 5 to 6 seconds that we can win at a certain cost, by the way. Nothing is free in the world. Low latency comes at the cost of quality, at a financial cost sometimes as well. But these were some of the key takeaways.
Great. So let's jump to the learnings. We've only got a few minutes left. Scott, maybe you could just talk us through some of the things that we've found on this journey.
Absolutely. John nailed it. Cloud production is possible. We still have some hoops to jump through. Everything we did worked. Do we have things to still harden? Do we things we need to do to make it more operational efficient? Absolutely. Everybody who's out on this floor today is working on this problem to make it better. No one's going to stop. I think we all know that this is where we're all going. One of my personal pet peeves, the lack of adoption of HEVC. I think it's time for us as an industry to finally maybe move out of the early 2000s and move into 2010 range and use a new codec. It certainly has matured a lot in terms of its ability to be used in the cloud. The concern that we started out with this project was, oh my gosh, it's going to be so inefficient to use HEVC on the cloud. We showed it wasn't as bad as everybody thought it was. Yes, there is a cost, but it isn't as terrible as everybody thought. UHD and HD are equally accessible. Again, there was concern from the broadcast community that UHD was going to be in a huge impact to this. We showed that we could do UHD. We did have moments where we had issues, even in the HEVC space, where certain times we had problems. We could not do things as well as we would like. I'm going to put a lot of that down to the fact that we worked under incredible pressure and short time frames due to COVID, but we had amazing people in this program who worked their backsides off to resolve those. My heart goes out to every one of the vendors and every one of the broadcast partners who showed up and tried to do this on incredible tight budgets against COVID, travel, and then 2 days of testing in Paramount Studios in London at the last minute, and then you staying up basically all night a couple times on holidays.
He did as well. He did, and yeah.
And then one last learning. It's on the next slide. NDI, NDI, which has kind of become the ground base of how we're getting a lot of our baseband signals up to the cloud. It's getting there. It needs a little bit of love. We do see things like Zixi and SRT out there. I think Ollie from MediaKind found some things that we're going to put together. I think they're in the repository now about things we could do to improve those protocols to make them more robust and resilient. They're great. I think going into the cloud, we need a little bit more work there. Operation delay matters, as John talked about, and protocols can help be tuned to decrease the latency. Mario said, yeah, you can get better latency, you pay a price. You go faster, you throw away B-frames, maybe your video quality is not as good. Is that important to you? You make that decision.
Thank you, Scott. The hardest one of all is where do we go next, Caroline? So what are you, in terms of your takeaways from this? It's a broad question, but what do you think?
Yes, it's about pushing boundaries. what was really useful about this accelerator exercise, we were able to shine a light on the edges. What are the areas that we need to delve deeper and do this collectively? Because we've all got the same set of problems. So doing this as a collective group has really accelerated our ability to see the areas that we need to improve. So scaling across all areas. So the acquisition, how do we get more feeds? How do we get feeds from multiple geographical locations? How do we come out of this controlled environment?
Yes.
That of course a network will always be a major factor, but how do we try and simulate a real life environment? And how do we also increase the production activity that is happening in the middle? How do we take graphics to the next level? How do we add commentary for multiple locations? And also on the distribution side as well, how do we get those feeds to land in all sorts of platforms and different geographical locations in the world? So more of a wider range of editorial and technical capabilities to see how far we can go.
Fantastic. Thank you so much.
So one last thing, I just want to say, and also a call for collaboration. I think some of you, if there are vendors in here, they will know that I've been speaking to many of you to ask you to join us in this quest to try and solve the live production and the cloud problem more quickly.
So we are actually calling for challenges for the next cycle. So we'll see. It'll be interesting to see where this goes next, including some of these areas. Thank you to all of you, Mario, to Caroline, to Scott and Jonathan particularly, not just for taking us through this, but for really leading this project in an absolutely articulate and amazing way. Thank you so much.
You're welcome.
We see quite a few of our vendors here that were involved in the project. So we see Theo and NetInsight and Zixi and a number of others. And the pod is just over here, literally just the other side of the aisle here, I think you put it on. And come and talk to the guys, come and talk to all the vendors involved, come and talk to the team. We can go into a bit more deep dive, and you can get this presentation and other things like videos and stuff at the pod there.
And
Thank you to all.
I think we can ask our colleagues to join the next accelerator.
Yeah, please do.
Because I think the idea it's really we broadcasters helping our partners to drive their products and offers and solutions. So it's really about sharing what we have learned and what are our problems, but our problems, they are the same. So join us.
Yeah. Thank you so much. Thank you. We're out of time. We better go. Thank you, ladies, for joining us here. Thank you very much.
Thank you.